Hi, I am Dr. Ruth Walker, and what I'm going to do today is just walk you through how to conduct a paired samples t-test in JASP. I will talk you through and introduce you to the data set that we'll be working with today, and just talk you through what's our research question, what are we going to be testing. We'll talk about the assumptions that you have to meet to conduct a paired samples t-test and whether or not our data meet those assumptions. Then we'll actually conduct the t-test and interpret those results together. So let's introduce ourselves to the data set that we'll be working with today. The data set we're going to be working with is from a published study by Banyard and colleagues from 2007. And what they did was they studied the effectiveness of a bystander intervention to prevent sexual assault. These types of programs have been pretty popular on college universities and campuses for quite some time now. What they do is they teach people who attend these interventions how to recognize risk factors and a situation where sexual assault or harassment could be a risk, and teaches people the skills and methods that they can use to safely intervene to prevent that from happening. So with this type of program, if you're not familiar with this, I just want to give you a little bit of background as to why these programs have become so popular. And so to do that, it's really important to just orient you with some of those statistics. More than 1 in 10 students report non-consensual sexual contact on college campuses. And this is from the 2019 Campus Climate Survey on Sexual Assault and Misconduct. These rates vary depending on the gender and of the participants who are responding. So if we're talking about people who identify as a woman or people who are transgender, non-binary, or queer, then they have significantly higher rates of non-consensual sexual contact compared to cisgender men, for example. In fact, 4 times higher rates. So for women who responded to this survey and people who identified as transgender, queer, non-binary, there were approximately 20%, or 1 in 4, who said that they had experienced non-consensual sexual contact. So as you can imagine, this is quite a big issue on college campuses, and a lot of work has gone into finding ways to prevent this and reduce these statistics. And bystander intervention programs are one of the answers to this problem. So let's look at the study design that they used and see what they did to study the effectiveness of their program. Their study design include 3 different groups of participants. They had a control group, which should be a key for you that we are talking about a group of people who, if we have a control rather, then we're talking about an experimental study. Second group, 1 session program. So these are participants that just attended 1 session of this bystander intervention program. And then additionally, a 3-session program. So these are people that attended the intervention program and then also got some booster sessions afterwards. The researchers measured participants on their different outcome or dependent variables at 5 different points in time. So pre-test, so before an intervention happened, post-test, after the intervention, then a 2-month follow-up, a 4-month follow-up, and a 12-month follow-up. It was a pretty sophisticated research design and a really great way of being able to test the effectiveness of their bystander intervention program. It is more than we are going to be able to analyze today. And it requires pretty complicated statistics that we are not going to be getting into. We're going to focus on a portion of their data and a portion of their research question so we can conduct our paired samples t-test. So for us, what we are going to focus on are participants in the 1-session program, so people who just attended 1 session of this intervention. And what we're going to look at is their pre and post-test scores. They were measured on several different outcome variables. The outcome variable that we are going to look at today is bystander self-efficacy. So bystander self-efficacy is really trying to get at how confident do participants feel in engaging in these different tasks or behaviors to prevent a sexual assault from happening. The idea being that people who've attended a bystander intervention program that teaches you skills would feel more confident in their ability to use those skills after attending the program than before attending the program. So what we're going to do is we're just looking at a piece of their overall study design. If you're interested in learning more about the different groups and outcomes and what happened with that follow-up data, it's really a well-done study. And I have a link to the study and that citation in the program video description below. So you can click there if you want to get more information on that. So for our research question, what we are going to be focusing on is there a difference in participant mean levels of bystander self-efficacy at time 1, so before the intervention, and time 2, after the intervention? Are those means the same or are they different from one another? And the people that we're measuring on bystander self-efficacy are the same people time 1 and time 2. It's just, we want to see, is there a difference in the same group of people before and after they receive this bystander intervention training? Our null hypothesis for our research question today is going to be, there are no differences in student levels of bystander self-efficacy before and after attending a bystander intervention training to prevent sexual assault. And our alternative hypothesis will be the opposite. There is a difference in student levels of bystander self-efficacy before and after attending a bystander intervention program to prevent sexual assault. So before we conduct our study, we have to meet some assumptions. So with the paired samples t-test, we're really looking at 4 different assumptions. So the first one is our independent variable, 2 categorical related or matched groups. In our case, they are related groups, that we have the same group of people before the intervention and the same group of people after. So we meet that assumption. Second assumption is our dependent variable continuous. The answer to that is also yes. So bystander self-efficacy is measured by assessing participants' levels of confidence on a continuous rating scale over multiple items. And so that total score ends up being a continuous variable that we can use for analyses today. And then our third and our fourth assumptions, we have to test those in JASP in the actual statistical program we're using. The third we're going to be testing for is in the different scores between time 1 and time 2, are there any outliers in those different scores in our outcome variable? And our assumption 4 is, are those different scores normally distributed? So one of the things that makes a paired samples t-test different from an independent samples t-test is that we have to look at different scores for our assumptions. To do this, you can calculate the different scores in Excel using a simple function. What you want to do is just subtract one mean from the other and look at that will give you the different scores pretty simply. I've already put those into JASP for us today. So it's already into our data set where we can use it. But if you were to do this on your own with your own set of data, that's something that you'd have to have calculated prior to doing these analyses. So for our data, I have an independent t-practice data set that we're going to be working with. Again, we're working with a piece of Banyard and colleagues' data from their 2007 study. So if you want the link to follow along and analyze this data with me, then just look in the video description. You'll see that there. You will also see the link to a JASP guide that will walk you through these analyses step by step as well. So what I'm going to do is I'm just going to transfer my screen over so I can share my JASP software with you. And let's go ahead. Share. So we are going to start off with testing assumptions. So we need to check for outliers in that difference score, and we also need to check for normal distribution. To do this, and you can see there are many more variables than what we're looking at today. So here we have our group, age, sex, year in school, religion, race. So many more variables than we're going to be looking at. What we're going to be focusing on here is pre-bystander efficacy, so pre-BSE. We're also going to be comparing that to post-BSE to see is there a difference there. And for the difference scores themselves, those are all separate variables here. So BSE difference score is here. If you wanted to look at any of these other variables after we go through this, so you can test your skills, see if you can go through this on your own, I recommend it. You can open up the Banyard and colleague manuscript and article and look through that to see what are these other variables. So here is rate with acceptance. This is bystander behavior. This is self-efficacy. So you can look at and make comparisons to see are there differences in these variables as well. So the first thing we want to do to get started is to relabel our group variable. This will make our job easier when we get to interpreting our results. So to do this, you just hover your cursor over group. You'll see that pop up, click here to change labels. So when you see that, go ahead and click. And you can see here the value 1. We're going to relabel this as our control group. Value label 2, we're going to relabel this our 1 session program. So those are the participants that we're going to be analyzing today. Those are people who attended a 1 session. And our 3 session program group for number 3. So with this, we are going to be analyzing the 1 session program. So what we want to do is filter everyone else out. To do that, under filter, you can see this check mark here by control group. We're going to click that so it's an X. We're also going to click here for the 3 session program. So the only check mark should be under or next to rather the 1 session program. And that's what we want to look at. So we can go ahead and X out. And when you look at the data set, you'll see this is now this lighter gray. And if you scroll all the way down, you'll see our 1 session program. It's in black, it's dark. And then if you scroll all the way down, our 3 session program participants are now light gray as well. So we have filtered out the participants that we're not interested in looking at for our particular research question today. So let's go up to descriptives. This is where we're going to go to test those 2 assumptions to look at our outliers and looking at whether or not our data are normally distributed. So clicking on descriptives, what we want to do is move over into this variables box or our outcome variables box, our difference score for bystander self-efficacy. So you can double click on that, or you can click and scooch it over with the arrow. So over here, we have bystander self-efficacy difference score. What we want to do is look at, are there any outliers here? So go ahead and click on plots and you'll click on box plots. I like to ask JASP you can see over here in our results, you can see already some dots outside of these whiskers here. I'm going to ask JASP to label those outliers so I know what participants they are. You can also ask JASP to click on the jitter element. What that will do is just plot all of the other data points in this particular group of participants if you wanted to look at that. Sometimes I think it can be a little noisy when I'm looking at outliers, so I don't always use it, but it can be really helpful. So I'm going to close up plots and click on statistics now, and I'm going to do that so I can look at skewness and kurtosis. That's what we're going to use to judge whether or not our data are normally distributed. So let's go ahead and start with our box plot since we already looked at that. I'm going to make this a little bit larger. And you can do that just by hovering over here and you can see where these arrows pop up. You can just pull this and that'll extend it and make that box plot larger in JASP. So just by looking at this, when we're looking at box plots, what we want to look for is, are our data points within these 2 whiskers? So here we want all of our data points to be within these 2. You can see participant 186 is down here, participant 150, and participant 231. So when we're assessing our box plots for outliers, we have 3 outliers in this data set. That might not be a big deal. So let's look at our normality statistic and see what that says. So when we're looking at our normality statistics, skewness and kurtosis, we want them to be within an acceptable region. And for that, there are different researchers that have different opinions on what that looks like. For some people, it's plus or minus 1. For other people, it's plus or minus 1.96. We like to use in my statistics classes just plus or minus 2 to make it a little bit simpler on us. So if you look here at this skewness statistic here, we have 2.907 rats. That is not between our acceptable range of -2 and +2. That's bigger than that. So that's not ideal. It means our data is a little skewed. And if we look down here in our kurtosis statistics, that is absolutely not within -2 and +2. We have a kurtosis statistic of 18.987. That is not good. And it is very common for kurtosis to be sensitive to outliers. So many times if we delete outliers in our data set, we can fix and improve these normality statistics. Not always, but they're oftentimes tied together, outliers and kurtosis statistics. So what I did for this particular data set, knowing that that kurtosis statistic is real ugly and very high, is I went ahead and I went in and deleted those outliers. So there is a second data set. You can go in if you want to and you're interested. You can go and open the data set up in Excel and delete these participant numbers from the data set and work with it then. If you would prefer, you can go ahead and open that second data set that I have in the shared Google Drive with all of these files for my videos in there, one that already has outliers deleted. So I'm going to go ahead and switch to that data set so we can take a look at how it looks different. So this is our new data set we're looking at with outliers deleted. So I'm going to go back up to descriptives, and I am going to put the bystander self-efficacy different score over here. And I'm going to go back and I'm going to click on those same boxes that we had just clicked on. I'm going to click on box plots. I'm going to ask JASP to label our outliers. Then I'm going to go down to statistics and I'm going to click on skewness and kurtosis. And then I will go ahead and go over here to our variable box. So let's see. Okay, this looks a little messy, right? I forgot a step. So we're going to take a quick step back and we're going to fix this. So go ahead and click on this arrow and this arrow. Let's go all the way back here to our data set. We're going to click on groups. So remember that filter step that we did with the original data set? Forgot to do that here. So let's click on group and we have our control group here. I'm going to relabel these really quickly. So 1 session program here and 3 session program here. Now this is the step that I forgot. I am going to filter out our control group and our 3 session group. So we should have X's there and just a check mark for the 1 session program. Now this looks how it's supposed to look in our data set. Let's go over to our results. Now this looks like how we want it to look. So if we're looking at our box plots, now we don't see any outliers on that box plot. That's great. Let's see, did this fix our skewness and kurtosis statistics? So skewness, we have 0.360. That's great, awesome. The closer to 0, the better for these statistics. So that is definitely within that acceptable range of -2 and +2. And going down here to kurtosis, -0.259, also within that range, also much closer to 0. So just by getting rid of and deleting those 3 outliers, we were able to clean up those normality statistics significantly. So our skewness and kurtosis statistics are now within a normal range. So we now meet those assumptions, so we can go ahead and move forward with analyzing our data. To do that, you're going to go up here to t-test and click on this, and then go down to paired samples t-test and click here. With a paired sample t-test, what you're going to be doing is moving your pre and your post measures over here. Whatever your variable pair is that you're comparing the means on, that's what you're going to put there. So we know that we're comparing pre-bystander self-efficacy, so that's there, to the post-bystander self-efficacy, post-BSE. So pre-BSE and post-BSE should be the variable pairs that you have there. Looking down here, we have other boxes and things that we need to check to get all of the output and results that we want. So I'm going to click on effect size. I want to make sure I get a Cohen's d value. And I'm also going to click on descriptives and descriptive plots. That helps me in terms of interpreting the results and what those mean. Once I have those boxes checked, I'm going to go ahead and click over here. And let's interpret our results. So first things first, looking here, this is our t statistic. Our t statistic here is negative 9.382. Our degree of freedom is 124. Our p-value is less than 0.001. And our Cohen's d value is negative 0.839. So if you were to report this in APA format, you would want to put this in the appropriate format for that. So you'd have t, your degrees of freedom in parentheses, equals your t statistic, comma, p is less than or greater than 0.05, and comma, d equals, and report that Cohen's d statistic. So what we need to talk about, though, is what this means. So what does this mean? To do that, we have to look at the p-value. So p-value less than 0.001. Our alpha level in this study and in most psychological studies, particularly social ones, is 0.05. So we want a p-value that is less than 0.05, which is awesome because in this case, our p-value is less than 0.001. So our p-value less than 0.001 is less than, smaller than our alpha level of 0.05, which means we are going to reject our null hypothesis. Anytime that p-value is less than our alpha level, then we're going to reject the null hypothesis. In this case, that means that there is a difference between bystander self-efficacy scores between time 1 and time 2. But how big is that difference? To get that answer, we have to look at that Cohen's d value. Our Cohen's d value is negative 0.84 if we round it to 2 decimal places for APA format. For Cohen's d, the different sizes of the effect are 0.2 for a small effect, 0.5 are larger for a medium or moderate effect, and 0.8 for a large effect. In this case, a Cohen's d value of 0.84 is definitely larger than 0.8. So we have a large effect size. So there is a difference in students' bystander self-efficacy scores, their confidence in their ability to intervene to prevent a sexual assault before the intervention and after the intervention, and that effect is large. With this, in terms of reporting, okay, so we know that there's a big difference. We know that it's a large effect, but did their confidence go up or did it go down? So that's the question. To get that answer, we're going to look at our descriptives. So here we can see our mean level of bystander self-efficacy before the intervention was 79.816. And here's our standard deviation. Our post bystander self-efficacy scores after the intervention is 86.84, and our standard deviation here. And this is where I think the plots also come in handy, because you can just look at the plot. If you know that you have a significant difference and you see the plot is going up or down, it tells you what direction those scores went in. In this case, our pre-bystander self-efficacy scores are much lower, significantly lower than our post-bystander self-efficacy scores, which is what we want. We want students who attend an intervention program to prevent sexual assault to feel more confident intervening to prevent sexual assault after they attend the intervention as opposed to before they attend the intervention. For this particular example, if you're interested in going through the JASP walkthrough, what it will do is talk you through how all the steps that we took together today in this video. It'll have pictures. It'll say, okay, if you're going to report this in APA format, this is how you report it. This is how you write this up. If you want to put it in a publication or in any type of research paper or things that you're doing for school, it'll walk you through how to do that. So all of that information is can be found in the video description. You can follow the links to the Google Drive where the data files are, as well as where that JASP guide file is. If you have questions for me, please don't hesitate to comment on this video. I'm happy to respond when I can. Good luck conducting a paired sample t-test in the future, and feel free to play around with this data set. There were lots of really awesome variables in this data set that the researchers looked at. So if you want to move on and look at bystander behavior or rate myth acceptance, that's something you can see. Did the researchers find significant differences in those as well? So thank you so much. And again, please don't hesitate to let me know if you have any questions.